Yes students, so welcome back to my video lecture 11 on S block elements. So in video lecture 9, 10, okay, we were talking about the different compounds of sodium. Okay, we have finished sodium hydroxide, we have finished sodium carbonate, and we were discussing about the chemical properties of sodium thiosulfate, wherein I have finished one chemical property, okay, that is iodometric titration. What is the chemical property of sodium thiosulfate here? Okay, yes, I have told you in my previous video that sodium thiosulfate, what is the formula? Okay, Na2S2O3. Sodium thiosulfate, okay, is a very good reducing agent. It's a good reducing agent, okay, but itself, okay, it itself gets oxidized. When it acts as reducing agent, it itself gets oxidized. It itself gets oxidized to what? Na2, okay, S4O6. What will be the oxidation state of sulfur in Na2S4O6? It's going to be 2.5. 2.5. Here what is the oxidation state of sulfur? It is plus 2. It is plus 2.5. Okay, is that simple? Now I told you, whenever, okay, sodium thiosulfate Na2S2O3 reacts with iodine, it reduces iodine to iodide, okay, but itself gets oxidized to what? Na2S4O6. okay, this reaction we come across in which type of titration? Iodometric titration. Iodometric titration. Okay students, now we shall complete the other chemical properties of sodium thiosulfate, which we just have two more chemical reactions of sodium thiosulfate. Okay, which are those two more chemical reactions of sodium thiosulfate? Okay, now next reaction of, okay, next chemical property, reaction of, okay, sodium thiosulfate with, okay, silver ions, Ag plus ion. Okay, yes, look here, very simple. It is very easy to write this reaction. It is very easy to write this reaction. What is it? Okay, what happens when sodium thiosulfate reacts with silver ion? Please, okay, yes, please remember the technique that I have told you. Whenever you are writing an ionic reaction, you just interchange the ions, isn't it? Whenever you are writing an ionic reaction, you just interchange the ions. Say yes or no? Okay, in sodium thiosulfate, which are the ions here? Okay, it is Na plus ion and S2O3 2 minus ion, isn't it? Is that correct? Okay, now we have silver ion, Ag plus. Now interchange. This cation will react with this anion, isn't it? Okay, the cation will react with this anion. And how do you write the product? Okay, crisscross method. How do you write the product? Crisscross method. Okay, so no, multiply this charge here, multiply this charge here. So what will be the product form? Ag2, okay, Ag2S2O3. Ag2S2O3, an unstable compound is formed, okay, an unstable compound is formed which will decompose to give silver sulfide, okay, which will decompose to give what? Silver sulfide, a black precipitate, okay, a black precipitate. This is actually a white precipitate, okay. This white precipitate is highly unstable. It will further decompose to give a black precipitate. What is that black precipitate? A black precipitate of silver sulfide. A black precipitate of silver sulfide is formed. Okay, is that simple? Therefore, sodium thiosulfate, okay, will react with silver ion to form, okay, an unstable white precipitate which further decomposes to give, okay, a black precipitate of silver sulfide. Silver sulfide. Understood? Now, the last reaction of sodium thiosulfate, okay, with chlorine and bromine water. Yes, reaction of, okay, sodium thiosulfate, okay, with okay, chlorine water, Cl2 water, okay, or bromine water, Br2 water. Okay, are you getting my point? Yes, look at here. See, when Sodium thiosulfate. Please remember the way I write the ionic reaction. Again, this is the 1000 times I'm telling you, whenever you are writing the ionic reaction, just interchange the ions. It will be very simple for you. Okay? Yes. And in a reaction, if you find any one of the reactant in zero oxidation state, then definitely the reaction is going to be a disproportionation reaction. That means the same element, the same reactant will be both oxidized as well as reduced in the given reaction, isn't it? Okay? It will be both oxidized as well as reduced in the same reaction. Understood? Okay. Now, what happens when sodium thiosulfate, okay, reacts with chlorine, okay, chlorine water? Well, okay, yes. So, chlorine is in zero oxidation state. Then definitely this is going to be a disproportionation reaction. That means one of the element will be both oxidized as well as reduced. Which element will be both oxidized or reduced? Here, okay, sulfur will be both oxidized as well as reduced. Okay, here sulfur is in which oxidation state? Sulfur is in +2 oxidation state. Okay, sulfur is in which oxidation state? Sulfur is in +2 oxidation state. Sodium thiosulfate reacts with chlorine, okay, and water to form, okay, it will form what and what? It will form, okay, yes, yeah, okay, it will form, okay, sodium sulfide plus sulfur plus HCl. Okay, look at here. Okay, sodium sulfide plus sulfur plus HCl. I hope you have understood my point. Any doubts with this? Okay, yes. So sodium okay, sorry, no, okay, extremely sorry. Now I told you that whenever it acts as a reducing agent, it will be oxidized to what? Na2, okay, Es4O6, isn't it? Okay, so in this case it is oxidized to what? 2.5. See the various products that are formed when sodium thiosulfate reacts with chlorine water. This is called as what? Chlorine water. Okay, yes, it will be both, sulfur will be both oxidized as well as reduced. Oxidized to, okay, 2.5 and reduced to what? Sulfur plus HCl. These are the various products that are formed in the reaction. Are you getting my point? So, okay, whenever you come across an element in zero oxidation state in a reaction, then in that reaction one of the element will be both oxidized as well as reduced. So sulfur is oxidized to, okay, plus 2.5, sulfur is reduced to zero oxidation state. Okay, so this is an example for what type of reaction? A disproportionation reaction. Okay, so chlorine is reduced. That means sodium thiosulfate is acting as a reducing agent. I told you, whenever it acts as a reducing agent, it itself gets oxidized to what? Na2S4O6. So guys, that is all about the chemical properties of sodium thiosulfate. Hope you have learnt it. Hope you have understood it. Okay. Now, so that is all about the compounds of sodium. Which are the different compounds of sodium that we have discussed? We have discussed about sodium hydroxide, okay, sodium carbonate, okay, and okay, sodium thiosulfate, Na2S2O3, isn't it? Na2S2O3. Are we clear? Are we clear? So these are the different compounds of sodium whose preparation, whose physical properties, whose chemical properties are well understood now. Okay. Now let us talk about some of the compounds of potassium. Okay. Yes. Yeah. Now let us talk about some of the compounds of potassium. Yes. Okay. Now we'll talk about the compounds of potassium. Compounds of potassium. Compounds of potassium. Well, here we will discuss, okay, the oxides of potassium. Oxides of what? Potassium. Then preparations of what? Preparation of potassium iodide. Preparation of potassium iodide. And then we will talk about the properties of okay, potassium iodide. Okay, So three things. One is oxides of potassium, preparation of potassium iodide, and the properties of potassium iodide. Okay, now coming on to oxides of potassium. Oxides of potassium. Yes, well, look here. Okay, potassium will form three types of oxides. Potassium will form three types of oxides. What are those three types of oxides? Potassium will form normal oxide. Normal oxide. Potassium will form superoxide. Superoxide. And potassium is going to form, okay, sesquioxide. 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 Are you getting it? Okay. Yes. So potassium is going to form three different types of oxides. Potassium will form normal oxide. Potassium will form superoxide. And potassium is going to form sesquioxide. Sesquioxide. Normal oxide means O, okay, 2 minus. Superoxide is O minus half. Okay. What do you mean by sesquioxide? If 3 atoms of oxygen combines with 2 atoms of other radicals, if 3 atoms of oxygen combines with 2 atoms of other radicals, then this type of oxide is called as what? Sesquioxide. Okay. So, okay, potassium is forming 3 types: normal oxide, superoxide, and sesquioxide. Sesquioxide. Okay. What is the formula for normal oxide? Just write K plus, okay, in all the case. So you just have to interchange the ions, okay, crisscross method. So what will be the formula of normal oxide? It is going to be K2O. Okay, it will be what? K2O. What is the formula for superoxide, potassium superoxide? It is going to be KO2, potassium superoxide. What about the formula for, okay, potassium sesquioxide? It is K2O3. K2O3. Are you able to understand? Okay. Formula for normal oxide K2O. Formula for superoxide KO2. And formula for sesquioxide, it is K2O3. Guys, when is normal oxide formed? When is superoxide formed? And when is sesquioxide formed? Okay. Yes. When do you get potassium oxide? When do you get potassium superoxide? And when do you get potassium sesquioxide? Sesquioxide. Okay. When are these 3 different oxides are formed? When do you get these 3 different oxides? Yes. Okay. When do we get these 3 different oxides? Well, understand here. When potassium is dissolved in liquid ammonia, okay, when potassium is dissolved in liquid ammonia, okay, reacts with oxygen. Okay, when potassium dissolved in liquid ammonia reacts with oxygen, it is going to form potassium oxide. That is the normal oxide. Okay, yes, this is going to form what? Normal oxide. Normal oxide. Okay, but if potassium directly reacts with oxygen, okay, if potassium directly reacts with oxygen, then we're going to get potassium superoxide. Okay, we will get what? Potassium superoxide. And if this potassium dissolved in liquid ammonia, reacts with excess of oxygen, if it reacts with excess of oxygen, then we will be getting potassium sesquioxide. Okay, what is this? Potassium sesquioxide. I hope you got it. Okay, sesquioxide. Yes. Okay, so when potassium dissolved in liquid ammonia reacts with oxygen, we will get potassium oxide. That is the normal oxide. When potassium directly reacts with oxygen, it will form superoxide. But when potassium dissolved in liquid ammonia reacts with excess of oxygen, it will form, okay, sesquioxide. What is the formula for sesquioxide? K2O3. Superoxide KO2. Normal oxide K2O. Simple? Yes. Now, okay, that's all about the different oxides of potassium. Let us understand the preparation of potassium iodide. Okay, another compound of potassium. Simple method. We have got a very simple method for the preparation of potassium iodide. Okay, what is that method? Look here. See, when potassium hydroxide, okay, aqueous potassium hydroxide solution reacts with hydrogen iodide. Okay, yes, when potassium hydroxide solution reacts with hydrogen iodide, okay, what is it going to form? What is this? H plus O, it is nothing but H2O plus what? Potassium iodide. Are we clear? Such a simple method of preparation of what? Potassium iodide, isn't it? When potassium hydroxide reacts with hydrogen iodide, it will form potassium iodide and water. Okay, are we clear? Yes. Now, okay, let us understand the properties of potassium iodide. Properties of potassium iodide. Okay, first one, look here. We will talk about the reaction of potassium iodide with okay, first one, iodine, reaction of potassium iodide with iodine, okay, reaction of potassium iodide, okay, potassium iodide with silver ion, okay, and then with okay, lead ions, Pb2 plus, and then we will talk about the reaction of potassium iodide with mercuric ion, Hg2 plus. So these are the different chemical properties of what? Potassium iodide. First with iodine, okay, and then with silver ion, then with lead ions, and then with what? Mercuric ions. Okay, now let us see what happens when potassium iodide reacts with iodine. Yeah, yes. First one, reaction with iodine. What happens when potassium iodide reacts with iodine? Okay, yes, understand the reaction here? Okay, yes, when potassium iodide reacts with iodine, okay, look here. Yes, what is it going to form? See, I have told you, if one of the element is in zero oxidation state, then okay, the reaction will be obviously what? A disproportionation reaction. Then an element will be both oxidized as well as okay, reduced. Listen here, when potassium iodide reacts with iodine, we will get okay, yes, we will be getting what? Okay, yes, potassium iodide plus iodate, okay, KiO3 plus H2O. Okay, wait a minute. There is something okay, wrong here. Yes, I'm sorry. Okay, yeah, reaction of well, okay, here I'm talking about what? Yes, what happens when okay, I'm sorry, extremely sorry, please kindly excuse me. Okay, this is not the reaction with potassium iodide. Okay, my question is, what happens when please understand the question. Okay, what happens when potassium hydroxide reacts with okay, yes, iodine? This is my question. Okay, what happens when potassium hydroxide reacts with iodine? Yeah, look here, let us now write the reaction. When potassium hydroxide reacts with iodine, understand the reaction. One of the element is in which oxidation state? Zero oxidation state. Then the reaction is going to be what? Disproportionation reaction. Then this element will be both oxidized as well as reduced. Look here, when potassium hydroxide reacts with iodine, it will be oxidized and reduced. Okay, yes, it will be reduced to potassium iodide but oxidized to potassium iodate. Okay, KiO3 is called as potassium iodate, and this is potassium iodide. What is the oxidation state of iodine in potassium iodide? -1. What will be the oxidation state of iodine in potassium iodate? It's going to be +5. Look at here. Okay, iodine is in zero oxidation state. Obviously, along with this, you'll be getting water, no doubt in it. Okay, now look at here. Iodine is in zero oxidation state, correct? Okay, so 0 to -1. 0 to -1, there is a decrease in oxidation number. Therefore, the decrease in oxidation number is called as what? Reduction, isn't it? The decrease in oxidation number is called as reduction. Now, 0 to +5. 0 to +5. There is increase in oxidation number. Increase in oxidation number is called as what? Oxidation, isn't it? So, in the same reaction, the same element is both oxidized, okay, as well as reduced. What do you call this reaction as? So, like this, you should be, okay, you should be blind enough to say, understand, please understand the concept, okay? It is, no, please do memorize this concept thoroughly. In a reaction, if you find one of the reactant in zero oxidation state, then, okay, in the same reaction, the element will be both oxidized as well as reduced. That means the reaction is definitely going to be a disproportionation reaction. So, what type of reaction is it? It's a disproportionation reaction. Proportionation reaction. It is a disproportionation reaction. Understood? Okay, are we clear? Any doubts with this? So, what happens when potassium hydroxide reacts with iodine? Okay, when potassium hydroxide reacts with iodine, we will get potassium iodide, potassium iodate, and water. Potassium iodate and water. Okay, yeah. Next, okay, let us understand the other chemical properties of potassium iodide. Yes, next question. What happens when potassium iodide reacts with Ag+? Okay, what happens when, okay, potassium iodide reacts with Ag+? Okay, Ag+, yeah, okay. What happens like that? What happens when potassium iodide reacts with Pb2+? Okay, what happens when potassium iodide reacts with Hg2+? Okay, understand this point here. When potassium iodide reacts with, or else you can also take, okay, yes, Cu2+. Okay, we can also take the reaction with what? Cu2+. What happens when potassium iodide reacts with Cu2+? Okay, can we write the reaction? When potassium iodide reacts with Cu2+, okay, see here we have potassium ion and iodide ion, and we have copper ion. What did I tell you? Okay, yes, the cation of this species will react with the anion of this species, isn't it? So that means copper ion will start reacting with what? Iodide. What are you supposed to do? You are supposed to, okay, yes, cross multiply the charges, okay, +2 charge here and -I charge here. So what is the product that is formed here? Yes, it will be giving, okay, yes, it will be giving what? Cu(I2), isn't it? +2 charge here and -1 charge here, Cu(I2), okay, and highly unstable compound. Okay, and highly unstable compound. Okay, yes, this compound will further react and it gets modified to Cu2I2. Okay, yes, it is a white compound. Okay, yes, what is the color of this compound? It is white. Are you getting my point? Yes. So when potassium iodide reacts with copper ions, okay, an unstable compound, which is that unstable compound? Cu(I2) is formed, which will further react to form a white colored compound. What is that white colored compound? Cu2I2. Okay, see, this question has been asked many a times. Okay, students will end up in this, okay, step. No, you're not supposed to end up in this step. Why you're not supposed to end up in this step? Because this is an unstable compound. Okay, this further reacts to form what? Yeah, Cu2I2. And what is the color of that compound? It is, okay, a white colored compound. I hope you understood my point. Yes. Next, okay, what happens when potassium iodide reacts with Pb2+? Okay, what happens when potassium iodide reacts with what? Pb2+. When potassium iodide reacts with Pb2+, again guys, the same reaction. Here we have potassium ion and iodide ion and, okay, lead ions, isn't it? So the positive charge of this species will react with the negative charge of this species. So what is the product formed here? We will get a black precipitate of potassium iodide. Okay, what is this? A black precipitate of what? Potassium iodide. Understood? Now, what happens when potassium iodide reacts with silver ions? Okay, silver ion. Okay, yes, yeah, very simple. When potassium iodide reacts with silver ion Ag plus, so here we have K plus and I minus plus Ag plus. The cation of this species will react with the anion of this species. Okay, so we will get what? Yes, an yellow precipitate. What is this precipitate? An yellow precipitate of silver iodide. Okay, when it reacts with, okay, lead ions, it will form a black precipitate of lead iodide. When it reacts with silver ion, it forms a yellow precipitate of silver iodide. When it reacts with copper ion, it will form a white precipitate of what? With copper ion, it is going to form a white precipitate of what? Cu2I2, isn't it? So now we will go with, okay, the reaction with a very, very important ion, that is mercurous ion. Okay, yes, yeah. Students, now, so we understood the different okay, yes, reactions. So let me just summarize this again. See, potassium iodide, okay, with Cu2 plus ion gives a white precipitate, isn't it? White precipitate. Okay, white precipitate of what? Cu2I2. Okay, with, yeah, lead ions, it forms a black precipitate, isn't it? Okay, a black precipitate of what? Pbi2. Okay, and with silver ion, yes, we will get, okay, a yellow precipitate. Okay, and this yellow precipitate of what? Silver iodide. Yellow precipitate of silver iodide. Understood? Okay, now what happens when potassium iodide reacts with, okay, mercuric ions? What happens when, okay, that means I'm talking about the last type of reaction of potassium iodide with mercurous ion. Okay, reaction of potassium iodide with mercurous ion. Look here, when potassium iodide, okay, potassium iodide reacts with mercurous ion, okay, mercurous ion, again try to interchange the ions. Okay, yes, try to interchange the ions, crisscross, apply crisscross method. Okay, so you will get an highly unstable compound. Which is that highly unstable compound? Hgi2. Okay, you will get an highly unstable compound. Which compound is this? Okay, mercuric iodide, an unstable compound. Now this mercuric iodide further reacts with potassium and iodine. Okay, mercuric iodide further reacts with, okay, potassium iodide. Okay, when it is further treated with potassium iodide, it forms a very, very, very important compound called as K2HgI4. This compound is called as Nestlers reagent. What is this compound called as? This compound is called as Nestlers reagent. Okay, and what is the, okay, color of this mercuric iodide? It is a scarlet red. Okay, it forms a scarlet red, okay, compound, which is a highly unstable compound. This further reacts with potassium iodide to form a very, very, very important compound. Okay, what is that compound? K2HgI4, which is called as what? Nestlers reagent. Where do we come across Nestlers reagent, guys? We come across Nestlers reagent, okay, Nestlers, okay, Nestlers reagent in the confirmatory test for ammonium, isn't it? In the confirmatory, okay, test for ammonium. Say yes or no? Okay, so we come across Nestlers reagent in the confirmatory test for ammonium. So, okay, when this Nestlers reagent K2HgI4 reacts with ammonium ion, okay, reacts with ammonium ion, we will get a brown precipitate, isn't it? We will get brown precipitate. I hope you have done this in salt analysis. Okay, so to ammonium salt, to an aqueous solution of ammonium salt, you will add Nestlers reagent. To an aqueous solution of ammonium salt, when you add Nestlers reagent, you're going to get a brown precipitate. What is that brown precipitate? The brown precipitate is like this: NH4 plus, okay, yes, HgO, okay, Hg. Okay, this is called as, okay, sorry, yeah, this is called as iodide of, okay, iodide of Millen's base. What is this called as? iodide of Millen's base. Are we clear? Okay, so this compound is called as iodide of Millen's base, and that iodide of Millen's base will give what? Brown precipitate. Okay, so students, I hope you have understood. So what happens when potassium iodide reacts with mercuric ion? It forms a scarlet, okay, red and unstable compound called as mercuric iodide, which further reacts with potassium iodide to give, okay, a Nestlers reagent, which is one of the most important compound in salt analysis, which is used for, okay, the confirmatory test for ammonium. So to an aqueous solution of ammonium, okay, salt, if you add Nestlers reagent, you will get a brown precipitate. What is that brown precipitate? It is nothing but iodide of Millen's base. Okay, so with this we have completed all the compounds of sodium and all the compounds of, okay, potassium. So in the next video we will complete all the chemical reactions of alkaline earth metals. Okay, thank you.